You know the drill, right? A friend or family member says they feel sick. And what's the very first thing we do? Yep, we put our hand on their forehead. We're trying to get a read on a fever, and we trust our own sense of touch to tell us the truth. But what if I told you our hands are, well, pretty terrible at this job? So let's just ask it straight up. Can you really trust your hands to tell if someone has a fever? It feels like it should work, right? It's so simple, so intuitive. But as it turns out, our sense of touch can be a really bad judge of reality. Let me show you just how unreliable it is with a cool classic experiment. And hey, you can totally try this at home. You just need 3 bowls. Fill one with ice-cold water, another with some warm water, and the one in the middle with just plain old room temperature tap water. Okay, so first, stick your left hand in the icy water and your right hand in the warm water. Just let them sit there for a minute or two. Then, at the exact same moment, pull them both out and plunge them into that middle bowl of room temp water. So, what do you think you'll feel? Okay, this is where your brain gets completely fooled. The water in that middle bowl is all one single uniform temperature. But to your right hand, the one that was just in warm water, it feels surprisingly cool. And your left hand, the one from the ice water, thinks the water's warm. Your brain is getting two totally contradictory messages from the exact same water. It shows that our sense of touch isn't really measuring temperature. It's measuring the change in temperature. The takeaway here is pretty clear. We just can't rely on our hands to tell us how hot or cold something actually is. This kind of begs a major question then. If our own senses can't be trusted for something so basic, how in the world do we get a reliable answer? How do we find out how hot or cold something actually is? Well, the answer is a scientific concept called temperature. See, it's not a feeling. It's not warm or cold. It's an objective, reliable measure. It's a number that lets us say without a doubt that one thing has a higher temperature than another. No confusion, no arguments between your left and right hands. And to get that reliable measure, we need a special tool, a device that was invented for this one specific job, to measure temperature. And that device, of course, is the thermometer. Now, here's the thing. Not all thermometers are created equal. So let's start with the one we're all most familiar with, the one designed specifically to measure the temperature of the human body. We've all had this number drilled into our heads, 37 degrees Celsius, or 98.6 Fahrenheit. It's pitched as the normal temperature for a healthy person. It's the benchmark. Anything above that, and you've got a fever. But here's a little secret. That normal temperature is kind of a myth. It's really just the average temperature taken from a whole lot of healthy people. Your personal normal might be a little higher or a little lower. Plus, it changes throughout the day based on your age, whether you just exercised, you name it. And this is the exact job of what's called a clinical thermometer. It's a specialist. It's built just for the human body, which is why its scale is so narrow, usually only from 35 to 42 degrees Celsius. Our bodies rarely go outside of that range, thankfully. And aren't we lucky that the modern digital ones we use now are way safer than those old mercury thermometers? These days, we even have the non-contact infrared ones that get a reading from a distance, which is a huge plus for not spreading germs. Okay, so let's switch environments. Let's go from the bedside to the science lab. What if you need to measure something way colder or way hotter than a person? You're going to need a different tool. A laboratory thermometer is a totally different beast. It's built for a much wider range, sometimes from -10 all the way up to 110 degrees Celsius. It's perfect for science experiments, but totally useless for measuring the subtle changes in body temperature. And here's a key difference in how you use it. You have to read a lab thermometer while it's still dipped in the substance. The second you pull it out, the reading starts to change. So we've gone from our own bodies to the science lab. But what about measuring the temperature of the entire world? You know, the air, the weather. This needs accuracy on a massive scale. This powerful quote comes from an incredible Indian scientist, Anna Mani. Her philosophy really captures why this all matters so much. When you're talking about something like weather forecasting, getting an inaccurate measurement isn't just a little unhelpful, it can be seriously dangerous. People called her the weather woman of India, and she was all about precision. She didn't just use weather instruments,
She invented and simplified hundreds of them. This was a huge deal because it dramatically reduced India's need to import these tools, which let the country generate its own accurate data. Her work was foundational, not just for meteorology, but it actually helped pave the way for India to become a leader in harnessing wind and solar energy, a true pioneer of measurement.
So let's just tie this all together. What have we learned? First, our hands lie to us. Touch is a poor guide to temperature. Second, temperature is the objective, scientific measure we can actually rely on. Third, there's a right tool for every job, whether it's a clinical thermometer for your body or a lab thermometer for an experiment. And finally, getting that measurement right is absolutely essential for our health, for science, and for just understanding the world around us.
And once we mastered this idea of reliable measurement, the scale of what we could suddenly understand just exploded. For example, thanks to these very principles, we now know that the core of our sun is burning at an unimaginable 15 million degrees Celsius.
And on the complete other end of the scale, we've also figured out the absolute limit of cold. It's a temperature called absolute zero, which is minus 273.15 degrees Celsius. That's the theoretical point where all particle motion just stops. It is the coldest anything can possibly get.
When you step back and think about it, it's pretty incredible. From the fiery heart of a star all the way down to the absolute boundary of cold itself, we humans have figured out how to reliably measure the universe. It really makes you wonder, what incredible, unknown temperatures are we on the verge of measuring next?